All right, all right. Those of you that just got in here, happy Thursday, even though we did play the Friday song. And the reason we played the Friday song is because no school tomorrow and spring break next week. So today's like a Friday. It's the end of the week for us. Um, Again, what we're going to do today is we're going to do the warm-up, which reviews SSS Similarity. Then we're going to talk about SAS Similarity. Then we're going to do our classwork and then your homework. Okay, if you finish the classwork, then you can start to have the class time to do your homework. And those are the only two assignments you're getting this week. So again, in order to maintain the A that you have for this new quarter, all you got to do is those two things. And in order to do those two things, you need to understand AA similarity, right? It's up here, AA similarity, SSS similarity, and today we're going to talk about SAS similarity. Okay, so let's go over this problem. And if you have any questions, please ask, please. Okay, so first thing we have to do is, well, we notice that this is the small and this is the large. Now we have to figure out, excuse me, if these are similar, what are the matching parts? So if I'm looking here, this triangle kind of looks like it was flipped over, right? Like it was kind of like flipped over this way. So the way I see it is I see this is the bottom and it matches with this one. And then this side flipped over here to that side. So those are the matching sides. And then that means these. So you see how it flipped over that way? Okay, that's what I'm guessing. So we're going to try it that way. So that's the first thing you need to do is find the matching sides. Okay, so I think we found the matching sides. So now what we do is we have to make ratios. We have to see, are these ratios between the sides, between the small and the large? And that's what the first thing you got to figure out. Are you going to do small over large or large over small? I'm going to do small over large. That's just my choice. So all my ratios are going to be small over large. So I have three ratios. I have the pink ratio, I have the green ratio, and I have the orange ratio. Okay, so let's do the pink ratio first. Pink ratio, if I put small, again, these are all fractions, right? These ratios are all going to be fractions. I'm going to put the small over the large. So if I look at the pink side, 15 is the small, 54 is the large. If I look at the green ratio, we have a decimal. Okay, I'm going to tell you how to deal with that in a second. So let's put the small of the green sides, 12 over the large, 43.2. Then I look at the orange, and I put the small, 5 over 18. Now what we've been doing is we've been simplifying these fractions. So if I look here, 15 over 54, I can simplify that. 12 over 43.2, that looks a little harder to simplify because I got a decimal. And then 5 over 18, there's nothing to simplify there. So what can I do? If I can't simplify these, how can I tell? You can say immediately, oh, well, since I can't simplify all of them, the answer is no. Well, not hold your horses. We got to try something here. So here's what I'm going to try. Since I see a decimal right there, I'm going to make all of these decimals. And let's see if that works. So what I'm going to do to make this a decimal, I just do 15 divided by 54, right? Top divided by bottom. So if I do 15 divided by 54, 15 divided by 54, right? Use your handy dandy calculator, and we get 0.2777777, and so on. Okay? Let's do this green one. 12 divided by 43.2, and we get 0.2777777 forever. So far so good. So far those match. Let's try 5 divided by 18. 5 divided by 18 is, you guessed it, 0.2777777. So guess what? Even though it didn't look like they were, because we couldn't simplify the fractions, when we changed them to decimals, they all changed to the same number. So all the ratios are equal. So we can say, yes, these triangles are similar. Yay. So now we're not done. We got to do one more thing. We got to say, okay, triangle blank, blank, blank is similar to triangle blank, blank, blank. Okay, so how do we do that? Well, let's find the corresponding parts. Now, it doesn't matter which one we start with first, as long as when we list the letters for each triangle, they match. So some of you might say, okay, mister, I'm going to start over here. I want this. I want P. What does P match with in the other triangle? Well, this is green, orange. So we look here, green, orange is Y, so P and Y match. So I'm going to put that first. P and Y match. And then over here, A. What matches with A? Well, that's green, pink. So we have green, pink over here. So A and T match. So A and T match. And then we look over here, R. R in the small triangle is pink, orange. And R on the big triangle is pink, orange. So R matches with R. Okay? So the way you did it, if you did it in a different order, as long as P and Y are in the same spot, A and T are in the same spot, and R are in the same spot. Like somebody might have said, oh, mister, I did triangle RAP because I like it says wrap. Okay. So if you did triangle RAP, make sure R matches with R, so you put R first here. A matches with T, so you put T second. And P matches with Y, so you would put Y third. Okay? So it doesn't matter what order you put them in as long as they match with the other triangle. Right? As long as P and Y are in the same spot, A and T are in the same spot, and R are in the same spot, because those are the matching pieces. Right? R, A and T, P and Y. Okay. Oh, and you say, yes, they are because of SAS similarity theorem. Right? That's why they are similar. All right. Any questions? This is SSS is what we talked about yesterday. So now we have two ways to prove or to show that two triangles are similar. We have AA similarity. We have SSS, side, side, side similarity. And now we're going to learn side angle side similarity. Okay? Which means I'm going to have, I think it's kind of obvious, right? You're going to have two sides that are proportional, and then we're going to have an angle that's in between them that's equal. Okay? So we're kind of combining the two previous theorems. So now here's the actual definition. If two corresponding sides, if two, again, pairs of corresponding sides are proportional, right? Proportional, that means the ratios are equal. And the included angle, remember, included means in between. The included angles are congruent, then the triangles are similar. So if we have two sides, two pairs of sides, so it's not SSS, we don't need all three. We only need two of them. So if we can find two sides and the angle in between those two sides is congruent, then we can say the triangles are similar. So I'll give you a second to copy that down if you don't have it printed out. And this is SAS similarity. This is the last theorem to prove triangles similar. We have a lot of people absent today. Some people are taking an earlier vacation than us. That's not fair. Maybe I should give extra points to the people that are here. All right, so let's look at an example. So let's determine if these two triangles are similar by SAS. So if we look here, I already see an angle. Do you see an angle here, guys? I see this angle is congruent to that angle. So that means This is congruent to that. I also see two pairs of sides. There's no value here, so it looks like these are the two sides, and that makes sense because those are the two sides that make that angle, and this is the angle in between. That's the included angle there. So let's see. So this side matches with this side. This side matches with this side. So we know the angle. So we have A already. We have A. So we know the angles are congruent, right? That is congruent to that because of this little arc right there telling us those two are congruent. So we're good. So now we just got to look at the S and the S. So let's look at this side, the orange side, and then let's look at this side, the pink side, and let's see if those give us the same ratio. So again, I'm going to go from, well, actually, let's go. I like to go the way the pictures go. So when you're deciding how to write the ratio, the way I do it, because some of you are saying, Mister, I don't know what to do, large over small or small over large. You say we have to choose, and some students are like this. They're like, when you make me choose, I have a hard time choosing. So okay, so if you're having a hard time choosing if you want to do large over small or small over large, the way I do it, hold on, somebody's coming in. The way I do it is the way the pictures are drawn. So I go from left to right. So we see it's large on the left and then small on the right. So I'm going to put large over small. Okay. And it doesn't matter. Just make a choice. If you don't want to do that, just make a choice. Doesn't matter. As long as you do both ratios the same way. So large over small. So the orange one is 8 over 6. And the pink one is 20 over 15. And so let's simplify both of those. Now you could do the decimal point, and some of you are saying, "Hey, Mister, can I divide with the calculator and get a decimal and do it that way?" Sure, you can do it that way. But if you see the fractions are simplifiable, just go ahead and simplify them. Right? So if I do 8 over 6, if I divide by 2, that's 4 over 3. If I do 20 over 15 and I divide those by 5, that's 4 over 3. And look at that. They are the same. They are the same. So now we have two pairs of sides that are proportional, and we have the angle in between them equal, so we can say yes, these triangles are similar because of SAS similarity. Yay. That's it. That's all you got to do. You just got to find two sides now, two pairs of sides that are proportional, have the same ratio, and then the angle in between them have to be congruent, and then you're done. And so now let's write our similarity statement. So triangle blank, blank, blank is similar to triangle blank, blank, blank. So we know K and N match. So K and N match, right? And then we can look here. If you want to do the other side, now that we know, if you want to do the other side, we can do this other side. And so now we can say, okay, right here, what does J match with? So I'm going to put J next. What does J match with? Well, J is orange, purple, and that's orange, purple, that's M. And then what matches with L on the big triangle? What matches with L? Well, L is on pink, purple. So we look over here. P is on pink, purple. So P is what matches with it. So there we go. K matches with N. J matches with M. L matches with P. And we're done. Okay. Any questions? Any questions? Okay, I'll give you a minute to copy that or ask any questions. Questions? Okay, I want you to try one. I want you to try one. Try number 6. And again, you're going to try to do angle similarity. So if you look here, again, there's a triangle inside another triangle. I would try to draw two separate triangles, the small one and the large one. Draw them separately and do this. So I'll give you 4 minutes. Alrighty, time is up. Time is up. So I drew the small and the large. I separated them. And if you notice, the small is ADE. That's what I drew right here. And the large is ABC. I drew that right there. Then the small has 15 and 12 as sides, right? 15 and 12. And the large gives you the whole side. The large has 25 and what? 25 and
21.
Yes, thank you. As the other sides. Right? So I wrote that there. And so now you're asking, okay, mister, we can see that this side matches that side, and this side matches this side, but what about the angle? Well, what's the included angle? The included angle is the angle in between them, right? So it's that angle. And if you look at this, don't they share that angle? Isn't that angle A the same here and here? It's the exact same angle, isn't it? So we can say, like we talked about yesterday, because of reflexive property, that angle A and angle A are the same, so they are equal to each other. So we have the angle. Yay. So if we're using SAS Similarity, we have the angle already. Now we just got to check the sides. Okay, so now we just got to check the sides. So let's check the orange side, and let's check the purple side. Let's do a ratio for each one. And now I'm going to do small over large, just because that's what I want to do. So let's do the orange, small over large. So look at the orange sides. The small is 15 and the large is 25. And if you look at the purple, the small is 12, the large is 21. The large is what?
21.
Okay, thank you. So if we simplify 15 over 25, I can divide by 5. I get 3/5. If I go over here, I simplify by 3. If I divide by 3, and I get 4/7. Okay, so we have the angle equal, but are the sides proportional? Are these proportional? Proportional? And the answer is no. In order to be proportional, the ratios have to be equal. So the answer is no. So we say no. These triangles are not similar. Okay? All right, so here's what we're doing the rest of the period. We are going to work on our classwork. And if you go to Schoology, right, go to Schoology. There it is. Go to Schoology. And oh, come on. Go to Schoology and log in. And go to our course. We still have the third quarter still in there for some reason. I don't know why. So if you go here to A4, click on that. Go to week 11. That's us, right? Today's the 25th. Click on that. And you look here and you see classwork. Are we similar? Okay, go to classwork. Are we similar? You can open it with Kami if you want to, or you can open it up here. And it's just some problems. Now here, there are 18 problems. Okay, there are 18 problems. Only do 9. Only do 9. You guys hear that? Only do 9. Okay, did everyone hear that? Give me a yes or a something. Thumbs up. And say a yes in the chat, or give me a yes on there, or give me a thumbs up. Only do 9. Why? So I'm giving you a break because you still have homework to do, right? You have homework to do. So what's due? And I made it due tomorrow. What's due tomorrow? This classwork and the homework. Homework, you do everything. Okay, the homework, you do everything. Okay, so the homework, you do all of this. Okay, all 16. Okay, so classwork, you only do 9. Classwork, you only do 9. Homework, you do it all. Okay, so I'm going to open up some breakout rooms if you want to go into a breakout room and work. The rest of the period, you're working on classwork and homework. And remember, the classwork, you only do 9. Classwork, you only do 9 problems. There's 18 you only have to do. If you do all 18, you do any 9 you want. Any 9 you want. You can do the first 9, you can do the second, you can do the odds, you can do the evens. Only do 9 problems. Yeah, somebody asked, so we only do number 9? No. You do 9 problems. There's 18 of them. And you can turn it in by Cami. Yes. And if you need help, if you need the weekend to do this because you want to look at the videos and stuff, yes, I know the videos would. I've tried to upload the videos last night and I kept getting errors, and halfway through they would stop uploading. So I'm going to try again to upload 3 videos, right? Talking about AA Similarity, SSS Similarity, and SAS Similarity. And they should be up tonight, hopefully. I've been trying the past couple of nights and I've been getting errors. So I'll try them on a different computer. And they should be up tonight so you can look at them. So if you need to review looking at the videos, I know it says they're due tomorrow, but if you turn them in the weekend, that's fine too. Or if you turn them in during the break, that's fine. I just don't want, the reason I put tomorrow as a due date, because I don't want you to work during the spring break. But if you turn it in during spring break, I will be okay. I won't mark points off, okay? And so